Hello, in this video let's discuss third question of today's contest. Given an m into n binary grid where grid of 0 represents an empty cell and 1 represents a mirror, a robot starts at top left of 0 to 0 and want to reach m minus 1 and minus 1. It can move only right or down. If the robot attempts to move into a mirror cell, it is reflected before entering the next cell. If it tries to move right into a mirror, it is turned down and moved into cell directly below the mirror. And if it moved down into a mirror and if it is turned right, it will directly land to right of the mirror. If the reflection would cause the robot to move outside, the path is considered invalid. Return the number of unique valid paths from 0 to 0 to m minus 1 and minus 1. Since the answer can be very large, return it to the modulo 1 and n plus 7. The constraints are n and m are up to 500 and values are only 0 or 1. So the first thing is, the question is saying that, for example, we are reaching mirror, then if we are coming from right, we will automatically land into left. And if we are reaching from above, and if the present cell is 1, we will automatically land into right cell. And if it is 0, if we come from right, then we will, if we are going to right, we will go right. And if we are going down, and if it is 0, we will go down. So in this way, we have to find the number of ways we can reach the final cell from 0, 0. So first thing is, let's say we have no mirrors. Then what can we do? Then it is simply, we are at I and j, then we have to find the number of ways to reach this. So if we are at this, we can go to right or we can go to down. So the number of ways to reach from I plus 1 to j, I plus 1j to m minus 1, m minus 1 is function of I plus 1j. So it will be simply function of I plus 1j and function of ij plus 1. But we also have mirror now. We also have zeros and 1, so we have to change this. So how can you do that? So for example, we are at 1. So if we are at 1, we want to know the direction from where we reached this, right? For example, we are at 1. If we come from top, the next one will be right one. If we come from right, the ultimate one will be down. So if we only have 1, then how can we know whether we have to move right or down? So obviously we also have to keep a direction, so that if we are coming from down, then we can go right. If we are coming from right, and then we can go down. So at 1 we are at 0 we can do both choices, but at 1 we can only go to down or right based on the direction we come. So not only function of I and j will help, function of I and j comma direction is correct here. So function I, j and right. So this is the function now. Now for example, we are at 0. We are at 0 and we are trying for 1. So if we are trying for 1, let's assume the current cell is 0 and we are trying to go to right. So now we are going to go right and that is 1. So where we will reach? So ultimately we will reach down. So what will be the new function? What will be the number of ways? It will be simply function of I plus 1, j plus 1 and 0, because we came from top and the cell is I plus 1, j plus 1. So the answer is equal to this. If the right is not 0, if the right is 0, what it means? It means that simply add. So if it is 0, we will land here itself. We will be there only. And the direction is right, is 1, because we came from right. So answer is equal to this. And similarly for down. So we got the answer of function of all. So we can simply return the answer. But is this correct? No. Because here we are not checking whether the present cell is 0 or 1. We are blindly thinking that the present cell is 0 and we are finding the answer. But that may not be the case. The present cell we are at maybe 1. So if we are at initially at 1, then we cannot do this, because if it is initially 1, then ultimately we cannot add these both. We can only come down or come right based on the direction we come. So here we are forgetting that the cell here, the cell we are at can be 0 or 1. So if it is 0, this will work, but this is not the case. Obviously it is a grid of 0 and 1. So middlely, for example, we are at this, and even if we are at 1, we are doing this operation, which is very bad, because we are thinking only right, and if it is mirror, we are taking care. But what if the present cell is mirror itself? So how can we handle that? So instead of thinking about the next cell or down cell, let's think of the present one. So for example, initially we are at 0. So we are at 0, then simply we can take both choices. So simply function of this comma 1 and function of this comma 0, because of the direction. And if the present cell is 1, so if it is simply 1, then if the function, for example, we are at function of I, j and right, and if the present cell is 1, so if the present cell is 1, check if this right is 1. So if the right is 1, then add the ways from left, from the below. If r is equal to 0, it means we came from up, so we will ultimately land to this. So direction will be 1. So in this way, instead of thinking, so normally what our idea will, what will be our idea, like we are at 0 and let's check about right and let's check out below, because we can go only right or down. So we may think that the answer will be simply dependent on this, but here we have to think about the potential, because if it is 1 then this will not be the case, so answer is wrong. So instead of thinking right and down, just simply think of present value. So if it is 0, we have both choices, so simply add both. If it is 1, then the final shell, we cannot add these both, right? If it is 1, we can only go down or we can only go right, based on the direction we come. So that is a simple case. So this is the case for 1. And now, but initially we are at 0 0. So so where we reached 0 0, we came from right or we came from top. So instead of thinking, we can just simply start from direction of 2, because here we are checking on the direction also, right? So what we are doing now, so we are checking first direction. So if the direction is 1, we are checking whether the potential is 0. If the potential is 0, then add both, because if it is 0, it is not dependent. If it is 1, so if we came from right and the potential is 1, so simply only add for function of I plus 1 I comma j plus 1, because we are going down. So this is the case. So here we are checking based on the direction, or we may not check also, but here we are using the direction. So initially if we are passing function of 0 comma 0 comma 1, then the other block will not run. And if it is 0, so instead of just thinking blindly, we can just do function of 0 comma 0 comma 2, so that it will handle both conditions. So let's check the code. We are making the sizes, and initially we are making -1 and function of 0 comma 0 comma 2. So we will handle 2 separately, so that we will add both. So that's why we are using 2 instead of thinking whether 0 or 1 is better. And now if we reach it n-1 return 1, because we got away. And if it is out of boundary, return 0, because it is given that if we go out of the boundary, it is not valid 1. So this is invalid, so simply return 0. And if it is already not computed, then simply return it. Else if d is equal to 2, so it means that we are at 0 comma 0, we are starting now. So if we are starting, then we can take both, so function of this and this. And then if the direction is 1, so if the direction is 1, then check if it is 1. So if the potential is 1, then we can only count below. If not, we can count both. And similarly d is equal to 0, both. And finally we will store the answer modulo in dp of I and z. So in this way we can find the answer. If you have any doubts, comment below. See you in the next video.